Now functions. Now let A and B be two non-empty sets. A and B be two non-empty sets. Then a relation. Basically function is what? Is the relation from A to B is function if every element of A has a unique image in B. So it should have, every element of A should have a unique image in B. We write as f is a function from A to B. Now, thus the relation from A to B is a function if domain of A, like domain of A has no two distinct ordered pairs in F have the same coordinate. So if we write the function in ordered pair, then in case of a function, no two ordered pairs in F must have the same first coordinate. Now this is, see, A comma B. Now if A comma B belongs to function F, A comma B belongs to function F, we write f of A equals B. So basically this is X, this is Y, and f of A equals B. So Fy is basically, you substitute the value of X in the function F to get Y. Now B is called the image of A under the function F, and A is called the pre-image of B. Now to illustrate function, again an example. A is 1, 2, 3, 4, B is 1, 4, 9, 16, 25. Now how the function is defined is f is x comma y. Now x belongs to A, y belongs to B, and y equals to x square. As we can directly see, 1, 1, 2 is 4, 3 is 9, 4 is 16. So that's how they are related. Y is equals to x square. Now we have to show that this is a function from A to B, and then it's obvious we will be finding its domain and range. Okay, so first of all, for assigning the values, now function will be, see, the function will be 1, 1. When x is 1, y is 1. When x is 2, y will be 2 square, 4. When x is 3, y will be 3 square, 9. When x is 4, y will be 16. So this is a function. Now we clearly see, like, every element of A has a unique image in B under the function f. So this is a function. The basic thing is that the unique image, like 1 has 1, 2 has 4, 3 has 9, 4 has 16. So this is what? This is a function. Now domain of function f, that is what? 1, 2, 3, 4. Range of f is 1, 4, 9, 16. 1, 4, 9, 16. And the codomain will be the set B. As we can see, is what? Set B, which is 1, 4, 9, 16, 25. So as we can see that range is a subset of B, because this set contains all elements of this. So range is a subset of B. Now another example. Now f is given as 1, 3, 1, 5, 2, 3, 2, 5, and g as 2, 1, 5, 1, 8, 1, 11, 1. Now the question is, which of the following relations are function? So among these two, which are function? Now see, as in case of f, the 1, this 1 has two images, 3 and 5, or according to the definition of the function f, that no two distinct ordered pairs in F have the same first coordinate. So they have the same first coordinate 1. So 1 is repeated 2 times. So F is actually not a function. Now come to the point G. 2, 1, 5, 1, 8, 1, 11, 1. Now we see that no two ordered pairs in F have the same first coordinate. They all are different and they all have a unique image. Have unique image, though it's all is 1, but still they all have a unique image. So G is a function. Real function. Now a function f a to b is a real valued function if a and b, if both a and b are the subset of R. Means the real function, they are called the real function or the real valued function. Now example, let the function be defined by fx is equals to 2x minus 3. Now find f0. Now to find f0, we substitute the value of x as 0 in the given function. So this f0 will be 2 into 0 minus 3. So f0 is equals to minus 3. For f5, now the function f5, this will be 2 into 5 minus 3. So basically replacing x by 5, this is 10 minus 3. That is equals to 7. Similarly, now take minus 2, f of minus 2. Now this will be 2, replacing x by minus 2 of minus 2 minus 3, which is minus 4 minus 3, which is minus 7. Okay, now the graphs of some function. So first is the identity function. Now first of all, what is an identity function? Now identity function is basically a function from real numbers to real number, which is defined as fx is equals to x. Fx is basically y only. So fx equals to x is an identity function. Okay, so if we say what's the domain? The domain of f is basically all real number. So its domain of f is all real number, and the range of f is again all real number. So that's an identity function. Now we know how to draw a graph. We take the tables, we round down the values of x and then the values of y. So in the identity function, whatever is the value of x is the value of y. So if you see, if you take x is minus 2, y will be minus 2, x is minus 1, y will be minus 1, 0, 0, 1, 1, 2, 2. Now if we draw the graph of this identity function, see, this is x-axis, y-axis. Now draw 0, 0, 1, 1, 2, 2, minus 1, minus 1, minus 2, minus 2. So this is the graph of an identity function, which is a straight line inclined to, or you can say x-axis. This is around, you can take 45 degree of angle. So this is basically a graph of an identity function. Identity function, fx equal to x, and that's the graph of an identity function. Okay, now constant function. So basically constant function is given as fx equals c. C is basically a constant. For this we can take an example. First of all, let's see what's the domain of f. The domain of f is basically it's R, the all real numbers. So whatever you keep the value of x, that will be defined. But the range of f, that will be a c only. C means that number only, because whatever you keep the value of x, that y has the same, y will be the same number. For example, you can take constant function as fx equals 2. Now see, whatever is the value of x, the y has to be 2 only. So in this case, domain of f is what? Domain of f is equals to all real numbers. Like whatever, domain is basically the value of x. So whatever is the value, so whatever you keep the value of x, that is defined. But the range in this case, now whatever you keep the value of x, it is always 2. So range is basically 2. So now we will draw the graph of fx equals 2 or y equals to 2. So now this is the graph paper. This is the graph for the constant function, and here the x-axis, this represents the origin 0, 0. Now fx equals 2. So x means y equals 2. So this is 1, this is 2. So this is the point. Now from here you draw a line parallel to x-axis. So this will give you the graph of function fx equals 2. Now what is fx equals minus 2? For fx equals to minus 2, again this is the origin, minus 1, minus 2. You draw a graph parallel to the y-axis. Now this is the graph parallel to y-axis, so this represents fx equals to minus 2. Now what if suppose I write fx equals 0. So fx equals 0 means y equal to 0. So y is always 0. So basically y is always 0 represents this line. Whatever is the value of x, y is always 0, which is the x-axis. So if you write y equal to fx equal to 0 or y equal to 0, this represents x-axis. X-axis. Now what if I write x equal to 0? Now x equal to 0, now you can see this is the line in which x will always be 0. So what is this? This is actually the y-axis. So x equal to 0 will represent y-axis. Polynomial function. So now polynomial function. You know, we have done what's a polynomial is. Now we can write polynomial function, just for example, like fx is equals to x cube minus 2x square plus 5. This is a polynomial function. Now we can write gx as 5x square minus 7x. That is a polynomial function, and hx as anything like 2x cube minus 5x square plus 7. So these all are actually the polynomial function. Now for an example, we take a simplest one like fx equals to x square. Now this is also a polynomial function. Okay, so first of all, fx equal to x square. Now what will be its domain? See, domain is actually all real numbers. So domain of f is all real numbers. Now range. See, whatever we keep the value of x, whatever we substitute the value of x, the y will always be positive. The range of f is basically x greater than equals to 0. All positive numbers. Now, to draw the graph of fx equal to x square, again we make a table. As you know how to draw the graph, we make a table of x, we write the values of fx. So you take it like this. This is the graph paper. Now see, f, the function is fx equal to x square. So if we put x as minus 2, x square will be 4. Minus 1, 1, 0, 0, 1, 1, 2, 4. Okay, now we have to draw the graph. So when x is 0, the y is 0. Okay, when x is 1, y is 1. So x1, y1. When x is 2, y is 4. When x is 1, 2, y is 1, 2, 3, 4. It's actually like this. So here, when x is minus 1, y is 1. So when x is minus 1, y is 1. When x is minus 2, y is 4. When x is minus 2, 1, 2, 1, 2, 3, 4. So this. Now if you join it by the rough hand, we get a graph, a curve which is like this. So this is the graph of y equal to x square. Now for again we can take a simple example like fx equals to x cube. For this, see, domain will always be a real number, because whatever you keep the value of x, that is defined. The domain of f is all real numbers. But here the range of f of this function is equals to, the range of f will always be equals to r, because this is an x cube. So if you keep the negative values of x, you will get the answer as negative. Now to draw the graph. Now again we make the tables first of all. So -2, this is x cube, -8. -1, this is x cube, -1. 0, 0, 1 cube is 1, 2 cube is 8. So now substitute the values. First of all 0, 0. So here is the point. Then let's take the positive value. You can take negative also. 1, 1. 1, 1 is here. 2, 8. 2, 8. 1, 2. 1, 2, 3, 4, 5, 6, 7, 8 is this point. Okay. Now -1, -1. X is -1, y is -1. -2, -8. Now -2. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. This is -8. So here are the values. So the graph joined by the rough hand, that will be again like this. It goes like this and this. So it's a graph. Okay, fx equal to x cube. Now, rational function. Now the functions of the type fx by gx, these are called the rational function, and is defined only when gx is not equals to 0. Now for the example we can take like fx equals 1 by x. This is also a rational function. It's defined only when x is not equals to 0. So what is the range of f? The domain. First of all, the domain. So domain of f is basically real number minus 0. I mean, this is x is all defined, but it will not be defined when x is 0. Similarly, range of f is all real number minus 0. The range will also be f minus 0, which is not defined at 0. So when we draw the graph, we know that we will make the tables, so that we can make any tables for that. So the graph of rational function will be like this one. As you see, this is the graph. Now, rational function. Okay. Now we know that fx is 1 by x. Fx is 1 by x. Okay. Now just see, if we keep on increasing the value of x, the y will decrease. And if we keep on decreasing the value of x, the y will increase. As in the graph, you see, as the x increases, like x is increasing from, as you go from here, the y will decrease. And as you can see, the x decreases, the y will increase. So same here for the negative values. Like if we take like minus, if you put the minus values of x, that means as the x will increase, the y will decrease. And as the x will decrease, the y will increase. So this is the rational function. Now the modulus function. Fx is equal to mod x, for x belongs to real number. Now basically how this is defined. See, fx is equals to modulus of x, which is then equals to, now you write x, okay, when x is greater than equals 0 and minus x when x is less than 0. As we know that mod of x is always greater than 0 for all x, means you will get only the positive values. So now when we have to draw the graph, so domain here, the domain of the function, domain of this function f is equals to all real numbers. You can write any real numbers, but the range of f will be equals to the positive real numbers. Okay, now again when we draw the graph, we substitute the values. Now this is mod x, so minus 3, x is minus 3, modulus of x will be 3, x is minus 2, modulus of x will be 2, minus 1 1 0 0 1 1 2 2 3 3. Now substitute the values. Now see, if you substitute the values, this is 1, this represent 1 1 2 2 3 3 4 4. Again, even when x is minus 1, y is 1, when x is minus 2, y is 2, when x is minus 3, y is 3, when x is minus 4, y is 4. So you get a graph like this. So this is the graph of the modulus function. So this is the graph. As you can see, the range is always positive, is always y is always positive, even though the x is negative, but y is always positive. This is the graph for the modulus function. Now, so our next function is the greatest integer function or the step function. Now if x belongs to R, x belongs to real number, then the greatest integer not exceeding x is denoted by this. Now this is known as the greatest integer function. So first of all, I should explain you what is the greatest integer function. By example, suppose if greatest integer function 2.01, so this will be 2. In fact, if it is 3.99, this will be greatest integer is 3. If it is like minus 1.3, so the greatest integer in this case is minus 2. Minus 2.1, minus 3. So this is how the greatest integer function is defined. Now, draw the graph of the greatest integer function. Now, if we look at the graph, see, the graph will be like this. I have already drawn. Now, from the graph, as you can see, these bold black points represents they are included, and the points which are in red, they are actually not included. So let's take an example. Now see, if it lies between 0 but is less than 1, take 0.9. Okay, now in this case 0.9. So by the greatest integer function 0.9, this will be 0 only. So 0, you can see every point, like whatever the value of x, 0 is included, 1 is not included, means 0 less than equals to x less than 1. The greatest integer function will be 0 only, this thing. For this, like 1 and 2, 2 is not included, take 1.3. 1.3, okay, 1.3, this will be 1 only. So hence, all the values from 1 but less than 2 will give you answer as 1. Similarly for this, take an example. Now, values like minus 3 is not included but minus 4. So if you take the value between these 2 points, like take minus 2.6, minus 2.6, so this is what? Minus 3. 6, the answer is minus 3. So whatever is the value between minus 3 but less than equal to minus 2 will give you minus 3. So this is the greatest integer function or the step functions. Now there are some simple operations on functions, which is actually, just discuss it. Like if there's two function f plus g of x, So this can be written as fx plus gx. Similarly, f minus g of x, this will be written as fx minus gx. A number into fx, basically alpha times of fx. Multiplication f dot g of x, that is equals to fx into gx. Now f by g of x, that is equals to fx over gx. This is how the operations on function